Welcome to the Doo Divas Smells Like Money podcast. I'm your host, Suzan Chin Taylor, CEO and founder of Creative Raven, the firm that helps wastewater industry contractors and manufacturers unlock the power of digital marketing, AI, and PR to boost sales and opportunities. Whether it's through our online marketing and lead generation programs or providing a fully outsourced marketing department, we are passionate about helping businesses in the wastewater and civil infrastructure sectors not just survive, but thrive in today's digital world. Each episode, I'll be bringing you expert tips and strategies to help you grow and succeed. Let's dive in. Well, hello, everybody, and welcome to this week's episode of the Doo Divas Smells Like Money podcast. We are continuing our conversation today with Howie Honeyman, who is an innovator and solutions developer at Forward Water Technologies. So welcome back, Howie.
It's good to be here. Yeah, thanks you.
Well, last time we were talking about water reuse and what we perceive as a coming water shortage crisis due to industrial demands, population demands, data centers, whatnot. But today, I really want to connect the dots for our listeners, especially, municipalities and also, industrial pretreatment, in that you said very, very clearly to me offline that your technology isn't meant for, and this is how you said it, I'm looking at my notes, isn't meant for after it hits the sewer. It's meant to prevent the problem upstream. And so I'd like you to explain that and where the technology sits as part of the industrial process stream, and what exactly is it?
Sure. So industrial users, look, many of them behave entirely responsibly, and I've got no negative comments there. But they're limited by the technologies that they can buy and they can put on the floor. So if they're producing water and they're not recycling it, or producing wastewater and not recycling it in a way that's efficient for their own operations, they've got a waste stream. And the traditional methods out there basically filter and largely techniques such as forced evaporation, energy intensive, or other membrane techniques such as reverse osmosis. And all of those are very valuable, quite usable, and very effective within their treatment capabilities. What we do is we tack on the end of those processes, and we take for instance, the membrane treated reverse osmosis discharge, or the wastewater from a reverse osmosis process. That's actually a suitable feed for our technology. And we can take that water and squeeze out 75% of the volume of that wastewater volume as clean reusable water. So now you're recovering even further amounts of clean water using a low energy membrane process that goes well beyond the reach of the conventional technology and steps into the boundary conditions where you're using really high energy techniques such as forced thermal evaporation or transportation and disposal down a deep well. And we're coming in and tacking on the end of their process train, taking what they would consider waste and repurposing that waste as clean water and taking that treatment path even further. So that's where we're different. And while we're doing that ideally at the industrial site. So that's why we eliminate the problem before it goes into the sewer, right? And I think there's a desire to be able to do that. It's both good for discharge requirements that the industry has to meet at the municipal level. It's great for downstream municipal treatment because they don't have all these other, at that point, low concentration contaminants going through that they have to fiddle with, right? So it makes the entire process train much more stable.
Now, when you said what types of industrial, I'm a little familiar with this, but I'd like to hear it from you as an expert in it. What type of industrial waste streams have the tendency to create the most intense problems for municipal treatment systems?
Yeah, well, I guess that's a very broad question, but I'll go there and probably you'll get some emails back saying, no, he's all wrong. Highly contaminated. We look at streams and we classify them as highly contaminated when they're high strength brines. That is liquids or water streams that contain high amounts of inorganic salts and metals. Okay. So dissolved ions, and I'm using salt in the term that a chemist would use it. So any metal or alkali metal associated with an anion, a complex anion, is a salt, not just sodium chloride, although often much of it is sodium chloride. So you're looking at all sorts of dissolved calcium salts, sodium salts, various sulfates, phosphates, all sorts of muckety muck of dissolved ions, including transition metals. Iron, nickel, as examples, are quite common in industrial streams. And so we're looking at those types of materials specifically. We also have the advantage, because of the nature of the forward osmosis process as well, of being fairly tolerant to some types or many types of organic species. So while we're not a primary treatment, we can tolerate high levels of things like high molecular weight soaps that are dissolved materials in the feed as well. So really quite a murky formulation of industrial waste is suitable for our intake. So I'm talking about sort of the baddest actors of the sort of out there on an industrial basis, and a lot of the waste that we want to treat is conventionally sent for what I refer to as burn, bury, and boil. You either burn it at an industrial facility for incineration, and there are waste streams, such as from the pharmaceutical industry, that require industrial incineration because you've got APIs in them, pharmaceutical ingredients. They have to be mixed with fuel oil and they have to be burnt. Very, very expensive, huge load of CO2, incredibly inconvenient, but that's what you need to do. Bury is sent for deep well disposal. So a lot of wells are set up across the country, across North America, for chemical disposal, where you pump the material down deep underground. Again, transportation, expensive. Those wells are actually filling up, and the various governments are not licensing new ones. So the bandwidth of the wells is becoming much more restricted. Subsequently, the price for disposal at those wells is increasing. And then boiling is sort of the last part, where you put it into a thermal evaporator and you change the water from a liquid to a gas, leaving the salts behind, which is great. But if anybody watched how much energy they put into boiling a pot of pasta, a lot of water, a lot of energy goes into boiling that water, which you really can't get away from. At the end of the day, if you're going to evaporate water, you've got a known amount of heat you have to apply, and off you go. You can be efficient with it, but you still need that. So we want to beat that paradigm right now. We want to capture the water that's in those difficult to treat waste streams, where we can show we can do it with a low energy membrane process, and we can enable that water recycling. And in some cases, the concentrate waste of those contaminants that we create on occasion has value in it. In particular, lithium salts are something that we've looked
Hmm. So in the waste itself, there may be extracted usable things that can be sold as a revenue stream.
Yeah, and this is we didn't come up with that idea. There's a lot of effort looking at
Sure,
it
there's a
in
lot of
the
things like that.
produced water in the oil and gas industries. Lithium is, for obvious reasons, has become quite intensely focused at. But if it's dilute, it's very expensive to capture. If it's concentrated, the chemical process for capture becomes far more economical. And
Ah.
whether it's a transition metal or an alkali metal or whatever it is that you've determined has value, it becomes far more effective to recover that material when it's concentrated.
From a municipal perspective, um, what do you think would happen, or what do you anticipate would happen if more industry went this route and recovered and reused their water instead of disposing of it?
Yeah.
And maybe we could
Well,
look at it from both perspectives, how it benefits the municipalities to encourage their industrial users to do this. But I'm also thinking from the industrial user standpoint, that's got to, in some way, for whatever it's going to cost them to bring your technology into the plant, they're going to get back that ROI very quickly on an ongoing basis on energy costs. Like you were saying, the burn, boil,
a
bury
very
scenario, any one of those sounds very, very expensive to me. If
yeah.
there's a way to cut those costs down, let's hear it.
Yeah, so I've talked to a CFO who's writing a $30,000 check every week to dispose of their industrial water, where we could have reclaimed 90% of it. And he's, those are the types of opportunities we're looking at. But to your point, you can offset the cost of our approach, because being able to return the water efficiently back to your processing. In some cases, we've talked to some specific manufacturers where their ability to access municipal water limits their ability to produce product. And because we can go back in there and reclaim over 50% of their waste as clean water, their ability to boost their production and hence their top line revenue has grown dramatically, right? So instead of throwing the water away, they're reusing it. Because they can reuse it, they can increase their production with their current capital, and that allows them to boost their top line revenue. Nobody saw that coming. We didn't see it coming until we started working out the math. So that's how reusing water can actually impact, not just reduce the cost of disposal, but actually find in some instances where you're limited in production by the amount of water you can, actually allow you to increase production rate. So by being able to reuse the water and compact the waste, you're seeing less of those fugitive materials going into the municipal stream. Check for municipal. In some cases where water is restricting production, your production rates go up. Check. And because you're throwing away less water, you've got a lower disposal cost. Your operational costs are saved as well. So check there. So it just seems to make a lot of sense to follow down the reuse pathway for
Oh,
everybody who's involved.
absolutely. And there's something, if you're forward thinking, and you were just mentioning in that scenario where a city would, it's going to limit how much that industrial user is allowed to have, that
Right.
as demands from their community or other industries starts to increase,
Yep.
everybody's going to feel the pinch of that, because it can't be, we can't always do what we've always done. And it's like, hey, listen, this guy needs water and this community needs water, so you're going to have less. Start thinking of that now, because it could, not the communities, municipal waste, distributors would, or water companies would want to do that. But who knows, there might come a time where they might not have a choice but to do that in order for everybody that needs water
So,
gets
so
access to water.
I can validate your prediction because this is actually occurring on a regular or routine basis in Mexico for obvious reasons is much more water stressed than the balance of North America. And the municipalities have routed the majority of the water consumption to the public because what can you do? You've got to keep people water for cooking and bathing, and that's essential. And where the short stick is being delivered is to the industrial producers. So that's actually where we've been doing some work. Being able to show companies to reuse the water allows them to continue production. But we've also run into that particular scenario at least once or twice here in Ontario and Canada, where we've got a fantastic amount of fresh water. A couple of companies we've spoken to that have limited their production because the municipality will not allow them to take out of the water table that they're situated in.
Wow.
So it's here now.
Yeah, it's here now. I mean, we don't even want to think about it. So now I'm going to ask a really loaded question, and I hear this with new technology companies all the time. It's something that I get on my soapbox about it, but I would love to hear from you. Just because you're coming from true north of, is it happening up there like it happens here? Is that, why is it when better solutions exist, industry tends to stick with what they know, and they're very resistant to adopt anything new,
Yeah.
even though
Well,
they know it's proven? Why? What do you take as the reason for that being
yeah.
so slow?
Well, I got two things on there. So any emerging technology is going to have some questions about it.
Sure.
I work in an industry that has been dominated by snake oil salesmen for decades.
Mm-hmm.
And I'm going to fully admit that there have been the water issue has been solved so many times for humanity that I dare not even count it. So there's been a lot of false promises, and so I feel, or my experience is that I have to overcome a skeptical engineering community that has heard the story over and over and over again, and companies have failed to deliver. So we take a fairly different tactic at Forward Water in that we make modest promises and deliver and try to over deliver as we demonstrate our technology. So that's one issue, but maybe that's a little bit too less general. More general, I also come across this situation. If you're running a large plant, if you're running a large manufacturing process, or you're part of a large municipal system, you have an engineering partner,
Mm.
right? You have an engineering consultant, and that engineering consultant is going to do two things. They're going to service you and provide you with good, solid advice, but they're going to make sure that their liabilities are covered completely too. So they're not willing to recommend a chemistry or an emerging technology or a proven but unscaled technology, whatever classification you want to put on
Right,
it,
right.
because there's liability issues associated around that. And working with engineering community companies for us has been relatively fruitless. We've had to find the needle in the haystack, which is the aggressive adopter within these industries or municipalities who wants to push the boundaries a little bit further. And we work with those groups, individuals, as we can find them, which are fairly rare, um, uh, to confidently demonstrate our technology without overselling it or overpromising it. So
Mhm.
it's really quite a learned process at this point. Um, and don't get me wrong, there have been some, there's some very good engineering companies out there, um, but they have their own business to run too, and so their
Sure.
interests, they serve their own interests, which is the nature of their work. Um, so those are the kind of barriers that I've come across, and why you don't see aggressive adoption. Now, having said that, when the right conditions can be created, emerging technologies can flourish. And I will tell you, I will point to Singapore. Singapore, which has a massive recovery capability, both for rainwater, industrial water, municipal water, and they have a vibrant technology adoption pathway. Things have failed at pilot scale.
Mhm.
And don't get me wrong, it's not that they're not perfect, but they have been able to identify the things that do work through a good program and get those things implemented. And their water recovery rates are phenomenal. It's a country that had to borrow water, buy water, but now as a city state, it actually produces a lot of its own water. Um, so you can right the ship um, if you have a situation that allows the emerging technology to grow.
So does Forward Water offer, paid pilot programs to those entities that, might want to see, is this a viable solution for our particular situation?
Yeah, absolutely. I mean, we built a transportable commercial demonstration unit that can operate at 50,000 liters a day, um, uh, to intake as side streams to show that the technology would work at a rationalized engineering scale. So that's the kind of client that we're sort of engaging with now. Um, it's it's a traditional pathway in the water demonstration space, so we're following the footprints in the snow, if you will, to
Hmm.
use a little Canadian colloquialism.
Yeah.
Uh, yeah, but we do have that capability. We do bring our equipment on site, and we do believe that it shows that it has the benefits that we purport it to have. Um, Everybody likes to see, touch, feel, and everybody likes to see their waste being handled as opposed to model wastes. So that's why we did that.
Yeah, that's an excellent thing that you offer. So now, where do you think the first big breakthrough for, I would say more widespread adoption of these kind of approaches, not just yours, but other things in terms of reuse with industries, do you think it's going to be that they're going to be forced by regulatory change, or is it going to be cost or water scarcity, or maybe a combination of all three? What do you see is going to be the thing that's going to move the needle?
I think it's all three, and I think you need to, go to the legs of the stool kind of argument here. You really need three legs to this stool to make it happen. And what's changed? Um, in the southwestern United States, you have this perfect storm or three-legged stool sort of occurring, and I think this is where you're going to see the breakthrough. You're seeing produced water is being identified as a potential value proposition now, not only from the fact that you can ideally extract clean water from it. It is water, so if you clean it up, you'll have clean water. It's got valuable materials in it from a lithium standpoint. So now the ability to concentrate, maybe there's revenue in there, and people are starting to really seriously look at. And the third leg of that stool, so you've got lots of water to treat. You're running out of places to deal with it. I mean, even Texas is having some issues with putting water in disposal wells at this point. Um, uh, but the third thing that's coming up is the state governments, particular Texas and Arizona, I believe, and such. are recognizing that the lack of water, the water scarcity in the future, which is crazy, right? They're thinking in the future, 5 years, 10 years, is going to be an economical negative impact on their state's economy. So now you've got the state economy or the regional economy. You're running out of water. You need new water, and you've got a possible way to actually extract more value out of that treated water by reclaiming the minerals. That's sort of creating the perfect storm or the three-legged stool that's going to be needed for adoption. And you're going to see companies like ours, emerging technologies, brought down and doing. Can you complete the process? Can you capstone the process so we get the right concentrate for mineral recovery, produce clean water that's good enough to go back into the municipal system
Right.
and enable a new water source for the region, given the fact that they're drying out at
Yeah, it is going to be a combination of things. And I know that, being an Arizona resident and just, how long the battle has been going on just over the rights to use the water along Colorado River.
Oh yeah, yeah. I mean,
California, Nevada, and yeah, it's
so
just,
there's a whole textbook story behind that, right?
exactly.
Yeah.
Who owns the water? It's like, okay, well, we all need it. Why can't we all own it? Well, I guess, nobody really owns it. So as far as forward water goes, what's coming down the pike for you, and what does success look like for you as a company with your mission in what you're trying to do to solve the water scarcity problem?
So, I mean, success for us is long-term established contracts for us to be able to come on site and provide a service to treat water on an ongoing basis. That's the business side, right? And I have shareholders. We're a publicly traded entity on the TSXV. I have to be very mindful of bringing value to those shareholders. That's the business hat. But for me, the long-term success is being able to stand back and look at a facility that we've installed, saying that it's returning 1 million gallons a month back to the industrial user for reuse, and getting to that point of a dry facility, a facility that no longer has to take in water, but uses that water as infrastructure. That, for me, that's success. That personal level of satisfaction is success. That will come along with the financial success, which of course I need to deliver. But I'm in this to be part of the solution for the long-term supply of water for everyone. That's the goal.
I love it. Well, Howie, thank you so much. I mean, this has just been so interesting about just the different ways we need to look at water and water reuse, that it's not this, infinite supply.
No,
It's
no.
it's a very, we don't like to think of it that way, but it is a finite supply and we have to protect it. And so with that, if there are folks that would like to get in touch with you, just one moment. The signal keeps going off. And I don't know if anybody noticed it, but we had a visitor that came through in the background. Our CEO, Raj, decided to make an appearance here on the screen behind me. Hey, it makes it all natural. We're all human, things happen. If they want to learn more about Forward Water and what you are offering for the marketplace, could you please give us your website address? And you and I met on LinkedIn, and so we'll have Howie's number and contact information in the show notes. But just quickly, if they're interested, what is that website address, please?
Sure, absolutely. www.forwardwater.com, just the way it sounds. And yeah, I'm available on LinkedIn, Howie Honeyman. Easy to find with a silly surname like that.
All right. Well, again, Howie, thank you so much. And, I wish Forward Water, much success in its endeavors. I think that you're bringing something very, very important to the forefront. And, we need it because water is life.
Absolutely, Susan. Thank you for the ability to have a little discussion around this. Enjoy the conversation. And it's great that you're keeping these topics visible for everybody.
Oh, well, thank you so much. And thank you, listeners, for tuning in. And until next time, keep it flowing. Thanks for tuning in to today's episode. If you're ready to take your marketing to the next level and start increasing sales and opportunities for your business, reach out to us at Creative Raven. We're here to help you thrive in the digital landscape. Visit creativeraven.com or click the link in the show notes below to schedule a call and learn how we can support your growth. If you enjoyed the insights on today's episode, be sure to hit subscribe so you'll never miss an update. Until next time, keep growing and keep it flowing.